So for module 3 we have around 7 questions, that is 4 questions based on NAS, and then 2 questions based on iScsi, and then 1 question based on Fcip and Fcip protocol stack. So we're gonna start with iScsi. So what is this? It's a internet based protocol that is establishing that establishes and manages connection between host and storage over IP address. So you're managing and establishing connection between host and storage over IP address. So what you're doing it is you're iScsi encapsulate this inner SCSI gets encapsulated in a data packet of 4 into an IP packet. Okay, so what happens is, and then this transports them to, through TCP or IP, TCP IP. So this SCSI is widely adopted for connecting servers to storages because it's inexpensive and then it's easier to implement. So what you're doing is this usually is used in places where FCSAN does not exist. You have a storage, you have an IP address. So what you have here is you have a iScsi gateway, and then you have a storage array. You have a FC port. Here what you have, if you have your FC port, then it will go through your gateway and then go to the storage array. Otherwise, what you do over here is you send it to your iScsi port for the same storage array. Okay, so what happens here is you have another bus connection, that is your iScsi HBA, that is your bus connection. So you have to talk about the components, that is you have an initiator, the host, this is the server that becomes a host, and then you have a target or the storage or iScsi gateway, that is this one, or your target, and then you have an IP based network over here, and then you have your iCSI capable storage. You have a iCSI capable storage that is deployed, and the host within the ISC can initiate direct communication. You are going directly from the host, right? So that is what happens here. And then you have one through FC frames. So your IP packet travels through that. So it gives you connectivity between IP and FC frames. Okay. These are your components. Your components are 1, 2, 3, 4 and 5. So now one of our iScsi question is done. The other one is iScsi protocol stack and iScsi PDU. So you have iScsi protocol stack. So here it uses an OSI model and it is of 5 layers. Okay, so it starts with data link layer, network layer, transport layer, session layer and application layer. You're skipping the physical layer and you're skipping the presentation layer. Okay, that is what is happening over here. And then you have in data link layer you have Ethernet, that is you're using the you're using cable to give your internet connection. And then network layer you have your IP address, transport layer you're using TCP, and then session layer you're using iScsi, and then application you're getting SCSI, because you're using IP over here, you're getting iScsi. Okay, what happens in Ethernet is through frames you have your iScsi initiator and the target. Okay, here frames, Ethernet is the data gets sent through frames. In IP the data gets sent through packets. In TCP the windows and segments, it is the data gets sent in windows and segments. In iScsi login and discovery happens, and then in the application layer you have commands and data which is being got. So what happens is your data is in the innermost part, and then you have your SCSI, iScsi, and then TCP, and then IP, and then Ethernet. So remember you have to write 5, totally 5 layers, but you have to number it up to 7. 1 and 6 is skipped over here. that is your physical layer is skipped, and then your presentation layer is skipped. So data link layer, network layer, transport layer, session layer, application layer. Ethernet, IP, TCP, iScsi, and then you have SCSI. Okay, so the same thing you have to write in points as this thing. You have to write the initiator and the target uses SCSI commands and responses to talk to each other, and the command descriptor block or data and status messages are encapsulated into TCP IP and transmitted across the network. So you're trying to send blocks of data, messages, everything, and then you're telling about the session layer which is happening, and then what and all happens in the session layer, that it is a reliable because you're using TCP. And then in iScsi session layer, it is responsible for handling logins and authentication and target discovery and session management. In TCP, you're using iScsi at transport layer to provide reliable transportation. TCP takes message flow and then windowing, error recovery and retransmission. And then it relies on OSI model to provide global addressing and connectivity. Layer 2 protocol in data link layer is it enables node to node communication through a physical network. Okay, so that is why we have our Ethernet over there. Then you have the second part of the question is iScsi PDU, that is protocol data unit. So this is used as information unit, and then this iScsi initiators and targets communicate through each other through PDUs, that is your protocol data unit. These discover and send commands and messages, and then they will receive it. So what happens in PDU is contain one or more header segments followed by 0 or more segments. The PDU is encapsulated into a I'll explain the diagram and then we'll see this. Here you can see that your iScsi PDU is encapsulated in an IP packet. So what happens here is, this is your PDU layer, this is a TCP segment, and then the whole thing is the IP packet. IP packet has a IP header, and then header and data digest. Then you have a TCP header. Okay, first we have an IP header, TCP header, and then basic header segment. Okay, you have an additional header segment, header digest and data. Once the data is header is digested, you have header data digest, because you have to add this data also. So what you're doing here is that to write the theory, you have more than one header segments followed by 0 or many. You have this IP header, TCP header, basic header segment, then you have an additional header segment, so you have more than one. Then the TCP header contains information, so your IP header contains information about packet routing information. Your TCP header contains information about guaranteed delivery of the packet of the data to the target. And then your iScsi header, that is your basic header segment. This gives you the exact extract of the commands and commands for the target which are used. In addition to this, an optional CRC is used to known as the digest, is to ensure that the data integrity is maintained. So it uses a TCP checksum and Ethernet CRC. The header data and the data digest are optional. They're optional used in PDU. This is used for validating the integrity and placement. And with that, other than the NAS topic, the last question we have is Fcip and Fcip protocol stack. Okay, now so what we're doing is, what is Fcip? That is fiber channel over IP address. So in this, you have a fiber channel, that is Fcip, is an IP based protocol. Both your iScsi and your Fcip is a IP based protocol, and then this creates a virtual fiber channel over an existing IP network that's used to transport SC data between different FC SANs. It encapsulates FC frames into IP packets. This provides a disaster recovery solution. What happens here is, we'll see the diagram first. You have physical media, IP, TCP, Fcip, Fcp, SCSI commands, and then application. So what happens here is physical media IP, TCP, then FCIP, because your FC gets embedded over here. Then you have Fcip, and then you have CSI, and then application. These three, your application, CSI data and status, and then FCP. All of these three happen in the FC frame. And then you have FCIP, TCP, and IP. That is your FC to IP encapsulation. They're responsible for FC to IP encapsulation. What happens here is that the FCIP protocol stack is shown below, and the applications generate SCSI commands and data which are processed by various layers of the protocol stack. Okay, so then what happens is the upper layer protocol. The upper layer protocol SCSI includes that the SCSI driver program that executes the read-write commands. This includes driver commands that executes read-write commands. So what happens here is below the SCSI you have a fiber channel protocol, the FCP protocol. So what happens here is your fiber channel frame whose payload is SCSI. So this happens over in SCSI, right? So that is what is given over there. Then you have an FCP layer that rides on top of you have an FCP layer that rides on top of your fiber channel transport layer. That is here. This is your transport layer, right? So this enables FC frames to run natively within SAN fabric environment. In addition, you have a FC frame that can be encapsulated into IP and sent across remote SAN over an. So to understand this, you can see here that you have an IP header, TCP header, FCIP header, and then you have an IP payload. So what happens here is your IP payload gets separated over here. FOC, that is FC reader, and then SCSI data, and then CRC, EOF. This is your IP packet, and then this is your FC frame. This FC frame gets encapsulated and then is part of the IP payload. So for the explanation of this, we can see that the FC layer encapsulates the fiber channel frames into IP payload and then passes them to the FCP layer. What happens here is that you have a TCP and IP which is used for transporting the encapsulated information across the Ethernet, wireless or other medias that support the TCP IP traffic. So encapsulation of FC frame into IP packets could cause your IP packets to be fragmented. Fragment and a data link cannot support the maximum transmission unit because this is carrying a much larger data, right? So that is why it may not support maximum transmission unit. And then when the IP packet is fragmented, it requires parts of the header that must be copied to all fragments. Then when TCP packet is segmented, you see that your normal TCP operations are responsible for receiving and sequencing the data prior to passing it on to the FC processing portion of the device.